This is the Vanfretti lab, but I call it Alset lab, and doesn't mean anything. I made up something. The reality is my excuse to call it Tesla without getting sued. So that's the lab, and I call it lab because it's a comprised of both people and equipment. And I work in something that I am calling, and I'm probably one of the few people that calls this electrified, cyber-physical electrified systems. And the reason that I'm calling it this way is because now I work with uh, things that are beyond power and energy in the traditional sense. And that's this stuff, which is the coolest things that you can imagine. So beyond the power plug, that is what everybody thinks, oh, electrical power, you just put a plug in the wall, that's it. But beyond that, really, this is the next revolution. This is what's changing the world. We're electrifying everything. So everybody's familiar with Tesla. That's just the tip of the iceberg. There's trucks being fully electrified, ships for cargo, planes, drones, and what I really wanted to come back to the US is to electrify weapons also. So Lockheed Martin has been making this, and I say that as a joke. My wife is looking at me as to choke me. But Lockheed Martin has been doing this weaponized laser equipment, and you basically have an entire power station on top of a submarine and a tank. So these are some of the things that are happening, and my research basically involves everything that is required in making those electrified systems happen. So I work in developing sensors, acquiring data, transmitting it through communication networks. So we have implemented protocols to do that. Using the data, analyzing it with signal processing techniques to extract information. And then and that's really here at the top of that, because it's very dangerous to do experiments with the kind of things that I showed you before, or the power grid, because you saw what happened in Texas. The kind of bulk of my work is in doing models and running them in simulators where you can attach sensors and controls to it. So using the data from those offline or real-time hardware-based simulations, I apply the similar techniques, but now on the simulation data, and we try to close the loop with autonomous controls or even a human-based interaction, which I call recommender systems for decision making. So that's what I've been doing kind of in the last few years. So my entire research is fully applied. So we basically do all of these techniques, but we have applications in mind from the beginning. I wanted to emphasize that, all the research is exciting, but what is most exciting is the people. So these are who really makes it happen. This is my team of PhD students right now and master students. And this is really what, we produce as the university's people that can make this happen. I have a few URPs every semester. Here you have the current team. And this spring, there were quite a few of ARC students that are helping us. As an example project is the cryogenically cooled superconducting based Cheetah propulsion power grid that is inside of this plane. So we're trying to design through NASA support in the Cheetah Center. So Cheetah means cryogenic high energy electrical technologies for aircraft. So we want to make a zero emission aircraft, which is powered by liquefied hydrogen, and we are trying to use superconducting technologies to minimize losses, but also to maximize power delivery. In this project, we're basically building multi-domain models. So not just the electrical, but also how the high temperature superconducting cable has to be cooled. So we're also modeling the thermal process of those cables, the power electronics, the motors that we use to spin the fans, and the thermal management. So all of the work that we're doing, there is some modeling. One of the undergrads that has been working with us is Eric Segerstrom. So I'm gonna give you these slides so you can go and watch that video on YouTube if you want to see. But we can't ask Eric as an undergrad to build the entire plane and get all the results. So he's making a mini scale model. So mini scale model based on this Quanser platform. So you can watch some experiments there. And he's basically doing the proof of concept of how we can build these multi-domain models at a very small scale, and then doing experiments of how we can characterize and parameterize the system. So this is really a baby scale we want to do. It's just the electrical and the propulsion, but it gives a proof of concept of how we can build these multi-domain models and how we can parameterize based on measurements. Another example of a project related to electrifying and integrating energy systems is combining microgrid networks with district heating and optimize them together. This is a new project, so I'll have some, I will be looking for undergrads to join us. All of the modeling work is usually made with the Modelica language. And here's another project that I wanted to highlight because I have an undergrad working on it. Just as you heard machine learning, we can recognize dogs or cats, but I can also recognize high frequency interactions between the controllers in wind turbines and the rest of the grid. And I do this with the same machine learning methods that are used to identify dogs and cats. So the difficult part is not doing that on a computer. The difficult part is doing that at the edge. And doing that at the edge is something that I've had a student called Shun Yao. He has been working with me since his Arch semester, implementing this in an embedded hardware platform from NVIDIA, where we do all the GPU-based machine learning inference in there, but also the data acquisition. So we built everything to be able to do this detection at the edge and learning at the edge. I have a lot of slides, so I'll just show you here some different hardware platforms in the lab that are used for different purposes. So that's a nice resource available. And finally, I want to pitch that you take my course on modeling and simulation. If you're interested, it's 4170 or 6170, where you will learn about using these modeling technologies and also doing with your laptop real-time simulation. You will not be able to do real-time simulation with your laptop for complicated things like I was showing you before, but you can do it for simple things. And I try to bring those to the classroom. I'm done. I try to do my best as fast as possible.
Great.